Hello everyone, this is Shrawan Sir, making maths simple for you. Welcome to my YouTube channel called Maths Academy. Today in this video, we are going to discuss one of the most important questions from trigonometry, which is frequently asked in the examination. Here we go. Dear students, the question is, prove that 1 divided by sin 10 degree minus root 3 divided by cos 10 degree is equal to 4. Dear students, this question is from the multiple angles of trigonometric ratios. So let's solve it. Dear student, at first we are going to take the LHS. LHS is equal to 1 divided by sin 10 degree minus root 3 divided by cos 10 degree. So dear students, by solving this trigonometric expression, we have to find the value of 1 divided by sin 10 degree minus root 3 divided by cos 10 degree is equal to 4. So at first we take the LCM. Dear students, at first we take the LCM of denominators. The LCM of denominators is sin 10 degree times cos 10 degree. So dear students, after taking the LCM, we'll do crisscross. 1 times cos 10 degree, we get cos 10 degree minus root 3 times sin 10 degree, we get root 3 sin 10 degree. Dear students, now in the next step, we need some manipulation. That means we have to multiply and divide the coefficient of each term by 2 so that the expression of the upper one will change in the form of sin A into cos B minus cos A into sin B. That means the expression of the numerators will change into the compound angles. So let's divide each term of the numerator by 2 and let's multiply it by 2 in order to balance the system. So let's divide the coefficient of the first term cos 10 degree. The coefficient of first term we can suppose 1. So dividing 1 by 2, we get 1 by 2 cos 10 degree minus root 3 divided by 2. Then we get root 3 by 2 sin 10 degree divided by sin 10 degree times cos 10 degree. So dear students, each term of the numerator we have divided by 2. So the coefficient of first term is 1. So when we divide 1 by 2, we get 1 by 2. And again, the coefficient of sin 10 degree is root 3. So if we divide root 3 by 2, we get 2. Now, so we have divided each term of the numerator, that means the upper expression, by 2. Now, in order to balance the system, we have to multiply the whole expression by 2. So this means we have to divide by 2 and multiply by 2 so that the expression of the numerator will change into compound angle. That means it will change in the form of sin A minus B or cos A minus B. Dear students, the coefficient of cos 10 degree is 1 by 2. So let us replace 1 by 2 by sin 30 degree, because we know that the value of sin 30 degree is 1 by 2. So let's replace 1 by 2 by sin 30 degree times cos 10 degree. So dear students, now the first term has been changed in the form of sin A into cos B. So our plan is to change the expression of the numerator in the form of sin A into cos B minus cos A into sin B, so that we can write it as sin A minus B. So our plan is changing the expression of the numerator in the form of compound angles minus. Dear students, now the coefficient of sin 10 degree is root 3 divided by 2. So we know that the value of cos 30 degree is root 3 by 2. So root 3 by 2 replacing by cos 30 degree times sin 10 degree, keeping as it is. Then the numerators we keep as it is. We don't make any change in the denominator. Sin 10 degree and cos 10 degree keeping as it is times 2. So this means while changing the expression of the numerator into compound angles, we have to keep in the mind that the coefficient of cos, which is 1 by 2, we have to replace by the value of sine, and the coefficient of sine, which is root 3 by 2, we have to write in terms of cos, so that the expression of the numerator will change into sin A into cos B minus cos A into sin B. That means we'll able to change the expression of the numerator in terms of compound angle, which is sin A minus B. So dear students, we know that sin A into cos B minus cos A into sin B is equal to sin A minus B. Supposing the first angle 30 degree as A and the second angle 10 degree, supposing it as B, then the expression of the numerator is in the form of sin A into cos B minus cos A into sin B. That means this is the formula of sin A minus B. So dear students, we know that sin A into cos B minus cos A into sin B is equal to sin A minus B. That means the whole expression we can write as sin 30 degree minus 10 degree divided by sin 10 degree times cos 10 degree, keeping as it is. And these two also keeping as it is, because the numerator we have multiplied by 2 and divided by 2. Dear students, let's do the further calculation. Sin 30 degree minus 10 degree dear students, 30 degree minus 10 degree we can write as 20 degree. So subtracting 10 degree from 30 degree, we get sin 20 degree divided by sin 10 degree cos 10 degree. So denominator keeping as it is, and the number 2 also keeping as it is. Dear students, now the upper term we have got sin 20 degree. So now we are going to change this into multiple angle. We know that 20 degree is multiple of 2. So we can write 20 degree as 2 times of 10 degree. Dear students, sin 20 degree we have changed into sin 2a form. That means 20 degree we can write as 2 times of 10 degree, so that we can use the formula of sin 2a. We know that the formula of sin 2 is 2 sin A into cos A. Dear students, we know that sin 2a, supposing 10 degree as a, sin 2a means 2 sin a into cos a. Dear students, sin 20 degree we have changed into sin 2 into 10 degree. We know that sin 2a means 2 sin into cos a. So 2 sin 10 degree into cos 10 degree divided by sin 10 degree into cos 10 degree times 2. Dear students, now we have got the terms of numerator and denominator same. So we can cancel sin 10 degree and cos 10 degree in cos 10 degree. So same terms we can cancel with each other. Then we have got the remaining term 2 times 2, which is equal to 4, and which is equal to RHS of our proof, that which is equal to RHS. So dear students, the problem is very simple. So let's review the solution of proof that. So at first we have taken LHS, then after taking LHS we have taken the LCM of denominators. So after taking LCM of denominators we can do crisscross. Then we have got cos 10 minus root 3 sin 10 degree. So we have to do some manipulations. That means we have to multiply by 2 and divide by 2. So each term we have divided by 2 and the whole expression we have multiplied by 2, and denominator keeping as it is. So replacing the value of 1 by 2, which is the coefficient of cos 10 degree, by sin 30, and replacing the coefficient of sin 10, which is root 3 by 2, by cos 30 degree. So dear students, the expression of numerator we have changed in the form of sin a into cos b minus cos a into sin b, which we can write as sin a minus b. So dear students, a means 30 degree and b means 10 degree. So sin a minus b, which is equal to now sin 20 degree. And sin 20 degree, we know that it is multiple of 2. So 20 degree we can write as 2 into 10 degree. Then using the formula of sin 2a, 2 sin a cos a, then cancelling the same terms, then 2 times 2 we have got equals to 4. So this is the proof of the question number 24, which is from trigonometry, and it is frequently asked in the SE examination. So dear students, if you want to take the screenshot of this solution, you can take it. Dear students, thank you for watching this video. I hope that you have understood how to prove the problem related to multiple angles of trigonometry. Next time we'll meet with a new content. Till then, bye. Have a nice day. Thank you.